Hello and welcome to Universe Sandbox 2. So I'm still sick, sorry for my voice, but wanted to kind of get this suggestion done because I actually plan to make this kind of a two-part video. This first part is going to be pretty simple, but let's go ahead and start a new simulation. I have a suggestion from Raris, Jaguar YT or YouTube, and he says, please launch a super dense Saturn with rings at another super dense Saturn with rings, please. Well, here comes the part 1 and 2. I don't really know what velocity to actually launch these Saturns at. So what I'm going to do is I'm going to place a still Saturn. Then I'm going to pause the game and launch another Saturn at this Saturn. And that's going to be this part of the video. The next part of the video, I'm actually kind of curious about some input from AAV. See if there's any specific way I should actually do this, because he's the original suggestor of this. Basically, the reason why we would do this is to basically simulate two galaxies colliding. Now, obviously Saturn is way too big of a mass for these small particles that actually orbit around it. But right now is the default 10 kilometers per second, and let's see what happens. Let's go ahead and add some rings there, and let's add some more rings there. And let's watch as these two slowly collide. Hopefully something interesting will happen with the rings. We'll let them proceed a little bit closer, and then I'll slow it down a little bit so we can watch as the collision happens. Oh, and there they go. It doesn't really look like it. It looks like most of it's probably at escape velocity. It doesn't show any sign of really slowing down. Pulling a little bit of this part of the ring in, though. That's pretty interesting. But the key thing that happened here is these have like 2,000 particles each, and the simulation did not lag on this small of a scale. See, the way the simulation typically works is if there's gravity at play here, the further these little objects are away from the actual main source of gravity, the more it tends to lag, and the larger the simulation is. So if we did a galactic collision on this scale, it would probably work pretty well. So I'm thinking that might be a good idea. To do it this way, I mean. Very interesting. Pulling these parts in, but these seem to have achieved escape velocity. Let's go ahead and just kind of confirm that. Yep, that appears to be what happened. So let's go ahead and check out Saturn. So it still has its kind of main ring, it looks like. Let me pause the game real quick and double-click Saturn. It looks like it still has its main ring. A little bit kind of obfuscated. It's a little bit, it's not so much of a disc anymore. The tons of these little tiny particles just kind of orbiting around in kind of a polar orbit. Kind of just everywhere. It's like shielded with its own little tiny dust and ice particles. Pretty cool. And the rest of the rings are just going everywhere. If that happened in our solar system, we would have dust everywhere and tons of ice everywhere, I would think. But there you go. That is essentially what would happen if we launched it at 10 kilometers per second. Let's go ahead and try something a little bit slower. Thing that will not achieve escape velocity. Place Saturn as a still object, and then place Saturn as a still object. And let's see what happens when we do this. Let's add rings to this one, and let's add rings to that one. As you see, they're heating up from tidal friction. But this should accelerate a little bit. don't think it's going to accelerate at such a speed that it's going to get up to 10 kilometers. Actually, it might. The velocity is right there at the top. Let's slow it down a little bit so it doesn't happen too quickly. The simulation performs more accurately the slower it goes. And it looks like we're going to reach around, we're probably going to cap out around 8 kilometers per second. And here they go. Oh no, it got over 10 kilometers per second. Interesting. But of course that velocity was going to happen regardless. Simply due to the fact that because I launched at 10 kilometers per second, it was already moving at that speed, so it probably accelerated even faster than what it just did here, because the initial velocity was greater. But it still appears these little particles are long gone. Their velocity is 15.5 kilometers per second. The ones that are maintaining around Saturn are apparently 31 kilometers per second, but that's like kind of in a rotational direction. No. I don't really understand that, I have to say. Oh wait, they're dropping. Yeah, a lot of these are moving around 30, but these are moving 26, and these vary a little bit, between 30 and 26, but these are already far enough away from Saturn that it doesn't really matter, I guess. These are very close to Saturn. What about these particles that are just escaping? These are moving 15 at this distance. These ones that are falling back in are moving at a velocity of 22.5. That one's 18.2. Is this one actually going to escape? Or is it going to fall back in? It looks like it's trying to escape. It might... Yeah, it's curving back around and it's going to fall in. So there you kind of go. That's kind of the idea. Like, these are moving around the same speed. Or at least some of these are moving around the same speed as the particles here. Actually, these might not have actually escaped. I think they're actually being pulled back in. A few of them might have escaped. They're kind of being dragged along, but I think Saturn's moving so fast that these are going to be abandoned. Okay, so that's interesting. Kind of shows the distance really does matter in this case. These particles actually stay in line with Saturn. And these ones, well, they're just long gone. Anyways, I hope that gives a little bit of information. I'm going to give this suggestion an actual attempt in probably my next video, which will probably be tomorrow. I do plan on playing some Astroneer and stuff today. But if you guys like the video, please leave it a like, and if you want to see more videos like this, please do subscribe. It really does help. Guys, in the next one.